Okay, 4.3 reaction stoichiometry. There's a word you haven't heard seen before, maybe. Most people don't use that in daily life. Stoichiometry. All right. What stoichiometry is talking about is if you have a chemical equation, which represents a chemical reaction, can we do numerical calculations on, or I should say using that chemical equation? So if I have a couple of things that are reacting, they produce a couple other things, can I figure out maybe how much reacts? Give me a number. How many grams? Or how much is produced? Again, can I do that numerical calculation on it? My very first thing to know about doing stoichiometry is that you absolutely positively must have a balanced reaction, a balanced equation, I should say. If it's not balanced, then you're violating the conservation of mass, and you're definitely not going to be able to do any calculations with it. So, absolutely, positively, check if it's balanced, and if it's not, just balance it quickly. Most reactions can be done pretty fast, the balancing. All right. Now, how do we actually do the calculation? Well, guess what? It's dimensional analysis again, getting the units to cancel correctly. And so in that sense, there's nothing new here. Let me do it with an example. 4.8 from the textbook. Let's read what that says. 4.8, there we go. It says, how many moles of I2 are required to react with 0.429 moles of aluminum, according to the following equation. So here's the equation for this reaction. We have aluminum reacting with iodine to form aluminum iodide. Hey, here's some nice cool pictures of it. Here we've got some aluminum powder sitting down there at the bottom, and here we've got some iodine vapor. I guess they blew it on it or something, and wow, chemical reaction starts to take place right away. Form that aluminum iodide. All right, first of all, is this balanced? Let's go back to my notebook here. Aluminum plus iodine to give you aluminum iodide. By the way, you could probably have written that yourself, knowing that aluminum is either by itself in 0 or it's in the +3. Hey, why is aluminum in the +3? Look at your periodic table. Here it is, aluminum. It's in this column here where, again, +1, +2, main group, I'm looking at +3s. So very often, yep, aluminum should show up as a +3. If it does, and iodine likes to be a -1, you should have probably been able to predict that that was the reaction. That was the equation. But it's not balanced. I've got one aluminum on both sides, but here I've got 2 and 3. 2 and 3, odd even, multiply everything through by 2. Okay, and so if I add 2 aluminums and 2 of these guys, then I've got 6 iodides, which I can get by a 3 here. Alright, so there I've got my balanced reaction. Now I can do my stoichiometry calculations. They said that I've got 0.429 moles of aluminum, and they're asking me how many moles of iodide are being produced. So I start my calculation off, 0.429 moles of aluminum, and I'm going to set this up so that my units cancel, as always. In my balanced reaction, my balanced equation, I've got, you see, 2 moles of aluminum react with 3 moles of iodine to produce 2 moles of aluminum iodide. They're asking me about this one. They're asking me about how much iodine actually react with those 2 moles, or those 0.429 moles of aluminum. So I want to convert, if you will, from moles of aluminum to what they're asking me about, moles of iodide. I can do this conversion step because I know the correct balanced equation. In the correct balanced equation, I have 2 aluminums reacting with 3. In other words, the coefficients in the balanced reaction, balanced equation. And there I put my numbers in. 2 moles of aluminum react with 3 moles of iodine. Right. Moles of aluminum cancel. Notice I put that on the bottom specifically so it does cancel. Right. And that leaves me with moles of iodide, which is exactly what they asked me for. So I can put my equal sign, moles of iodine are my units, and finally pick up your calculator. 0.429 times 3 divided by 2 gives you that. So I'm using, here's the big key thing here, I'm using a conversion step that comes from the balanced equation. Notice if they had asked me about aluminum iodide, I could have done that as well. Instead of putting moles of iodine on the top with a 3, I would put moles of ALI3, and the coefficient would have been a 2. Once you know moles of one thing, you can always figure out anything else in that balanced equation. Alright, so let's try example, well, let's take a look at it anyway. Example 4.9. It says how many carbon dioxide molecules are produced when 0.75 moles of propane in a combusted according to this reaction. So they give me the reaction and, oh, that's nice, they balanced it for me. So I would do that exactly the same way as I did the other one. Let's go on to something a little more complicated. Example 4.10, let's pull that up here. 4.10 says what mass. So now instead of asking me for moles, they're asking me for grams, mass. What mass of sodium hydroxide is required to produce 16 grams of antacid milk of magnesia, which is magnesium hydroxide? And they give me the reaction. Notice I can look at this reaction and I could classify it as a double displacement reaction. The magnesium is kicking out the sodium to give me magnesium hydroxide. Sodium is kicking out the magnesium to give me sodium chloride. Right. And I look at this aqueous, aqueous, solid, aqueous. So solubility rules predicted that that one is a solid. So again, a metathesis reaction here. And nicely, they've balanced it for me. I might want to check just to make sure. All right. I'm going to write this. Let me remind myself here. I'm trying to produce 16 grams of this magnesium hydroxide, which is right here. So what I like to do is write out the equation and then write underneath it what I know and what I'm trying to look for. So there it is. Here's my balanced equation, just like the one that they gave me. They said I had 16, or I want to produce 16 grams of magnesium hydroxide. And the question was how many grams of sodium hydroxide are needed. Okay. 16 grams, that's what I know. That's what I'm going to start my calculation off with then. That's the amount of that product that I know I need to produce. Alright, so my calculation down here, there I started off with 16 grams of magnesium hydroxide. I want to go from magnesium hydroxide to sodium hydroxide, one thing to another in my balanced equation. However, these numbers out in front do not relate grams. These coefficients out in front relate moles or molecules, not grams. This is not saying 1 gram of magnesium chloride reacts with 2 grams of sodium hydroxide. No, that's wrong. It's saying that 1 mole reacts with 2 moles. So if I want to use my conversion step to go from one species to another, I absolutely must go to moles first in my equation, in my solution, I mean. And so I've done that, and we've done that for many chapters now. How do I convert 16 grams of magnesium hydroxide to moles of magnesium hydroxide? I use the formula mass. Formula mass, I got 1 magnesium, 2 oxygens, 2 hydrogens. Add that up, it turns out to be 58.3 grams. So I'll put grams of magnesium hydroxide on the bottom purposefully, so it'll cancel with these guys. Moles is what I'm converting to. That goes on top. And then my numbers. 1 mole is 58.3. At this point, I've made it to moles of magnesium hydroxide. Once you've got to moles, you can use the conversion from the balanced equation to go to anything else you want in that entire reaction. For this, they asked me about sodium hydroxide. So I want to go from magnesium hydroxide to sodium hydroxide. Right now, in my calculation, magnesium hydroxide is sitting here on the top. So in my next conversion, I put it on the bottom so it cancels. What I'm going towards is my sodium hydroxide. That's now on the top. What numbers do I fill in there? From my balanced equation. According to that, 2 moles of sodium hydroxide. So there we go, is 2 on the sodium hydroxide line. And 1 mole of magnesium hydroxide. There it is on the bottom. Alright, moles and moles cancel. Now I've got moles of sodium hydroxide. I'm almost done. They asked me for grams, not moles. And again, we know how to do that. Convert from moles to grams. I need the formula mass. 1 sodium, 1 oxygen, 1 hydrogen. Turns out to be 40. I fill that in. I'm not going to talk about the details there. You understand that by now. So everything cancels except for grams of sodium hydroxide, which is exactly what they asked me for. Put my equal sign, put my units, and finally pick up your calculator and multiply this all out. 16 times 1 divided by 58.3 times 2 divided by 1 all the way through. 22 grams is the answer. So going back to the equation, we're trying to produce 16 grams of magnesium hydroxide. I said, hey, how much sodium hydroxide do I need? Well, my answer is 22 grams. That's how much I'm actually going to have to start with.